Okay, we will start. Now in the morning class, what we have discussed is the functions of various layers in an OSI model. You have got 7 different layers in the OSI model. Now what were the specific responsibilities of each layer? The topmost layer is the application layer. Then the layer below it is the presentation layer. Then you have got the session layer. Now these 3 layers are called the user support layers. Now the 4th layer is the transport layer, and the 1, 2, 3, first, second, and the 3rd layer are the physical, data link, and the network layer. So these 3 layers, they are generally called it as the network support layers. Now, dealing with the first layer, that is the topmost layer, application layer, it provides services to the user. Second one was the presentation. Specific responsibility of the presentation layer was translation, compression, and encryption. Then the third one was the session layer. Its responsibilities include session management, authentication, authorization, and synchronization. Then comes the transport layer. Now, transport layer, its main function is the process-to-process delivery of the entire message, right? Now, the important functions of this transport layer includes segmentation, flow control, and error control. Then comes the network layer. Network layer is responsible for the source-to-destination delivery of the entire message. And there you have logical addressing and routing, and also path determination is there. Then comes the data link layer. Data link layer, the data unit is called it as frames, and its main function includes similar to that of the transport layer, like flow control, error control, etc. And they are responsible for the hope-to-hope delivery or node-to-node delivery of the data. Okay, and the last layer is the physical layer. Physical layer is responsible for the representation of bits, how you have to represent it, what are suitable for the transmission medium. I hope you have understood all the 7 layers function. Yes or no? Hope you understood?
Yes.
Yes, okay. Now we will move on to the next protocol or the next model called the TCP/IP model. TCP/IP means Transmission Control Protocol, Internet Protocol. So actually, this is another network model, and this was developed prior to the OSI model. Before finding out or developing the OSI model, this TCP/IP model was developed. So when they developed in the first time, it was defined with 4 layers. One is the host to network layer, the internet layer, transport layer, and the application layer. So initially, you have got 4 different layers of the TCP/IP protocol. One is the host to network protocol layer, then the internet layer protocol, and transport layer, and the application layer. Okay, now when you compare this TCP/IP with that of OSI, you can tell that this host to network layer is similar to the physical and the data link layer of the OSI model. So it is similar to the physical and the data link. Now, internet layer, it corresponds to the network layer of the OSI model. Now, transport layer as it is, and the application layer includes the presentation, session, and the application layer of the OSI model. Okay, and also this transport layer. Now, whatever was the responsibilities of the session layer in OSI model, a part of that is done by the transport layer in this TCP/IP. So I can define, so when you are comparing all these things, now this TCP/IP, it is made up of 5 different layers. One is the physical, data link, network, transport, and application. Okay, so but the application, it involves the presentation and the session layer, but generally you can have got the 5 different layers in TCP/IP. Now, what are the protocols in each layer? I told all these layers are nothing but they are the package of some protocols. Now, considering the physical and the data link layer of TCP/IP, you don't have any specific protocols in that layer. You can see in the diagram, protocols defined by the underlying networks. You don't have any specific protocol. You should use only this protocol in physical and nothing like that. They can use any proprietary or the standard protocols. Okay, so that has been used in physical. Any type of protocol can be used in the physical and the data link layer. Now, the next layer is the network layer or the internet layer. There you can see the main protocol is the IP, that is Internet Networking Protocol, and it is supported by 4 other protocols called ARP, RARP, ICMP, and IGMP. So network layer, the protocols that is supported by the network layer in TCP/IP are the Internet Networking Protocol, ARP, RARP, ICMP, and IGMP. Now, what is this Internet Networking Protocol IP? IP is the transmission mechanism used by TCP/IP. Actually, it is an unreliable connectionless protocol. Connectionless, you should understand what it's connection oriented and connectionless. Okay, you don't have any specific physical path over which the data travels. Okay, so Internet Networking Protocol is an unreliable connectionless protocol. Now, I told they are supported by, it is supported by the other 4 protocols. One is called it as the ARP. ARP means Address Resolution Protocol. Address Resolution Protocol. Now, what is its function? It is used to find the physical address of a node if we know the IP address. See, all the nodes have got IP address as well as a physical address. So if you want to find out the physical address by knowing the internet address or the IP address, you are making use of this ARP protocol. So using ARP protocol, you will be able to identify the physical address of a particular node. This physical address, it will be changing. Once when you go from node to node, this physical address goes on changing, but the IP address does not change at all. Okay, so ARP is used to find the physical address of the node when its IP address is known. Now, other type of protocol is the RARP, Reverse Address Resolution Protocol. A reverse address resolution protocol means if I know the physical address and if I want to find the IP address, I will make use of this RARP. But this type of protocol is used only when a computer is connected to a network for the first time. So initially only they will be making use of this RARP protocol. If I want to connect it to a network, if I want to connect to a network for the first time, I will be making use of this RARP protocol in order to identify the logical address or the IP address. The physical address I'll be knowing, but the IP address I won't be knowing if I'm connecting for the first time. So if I want to know that, by making use of this protocol, I can get that. Okay, so 2 protocols, ARP and RARP. Now the next protocol is ICMP. ICMP means Internet Control Message Protocol. Internet Control Message Protocol. Actually, this is used by host and gateways. Gateways are nothing but interconnecting devices. Suppose if there is some problem with the packet, what it is being received, then this protocol informs the sender about that. Okay, some control messages are passed. It sends query and error reporting messages. Okay, so if you have any doubt or any error in the transmission of a particular packet, then this ICMP reports that to the sender. Okay, now IGMP, Internet Group Message Protocol. Internet Group Message Protocol, it is used for the simultaneous transmission of a message to a group of recipients. If you have a group of recipients or group of nodes, then if you want to transmit a message simultaneously, then you will make use of this Igmp protocol. Okay, so these are the types of protocols that is supported in the network layer of TCP/IP. Main protocol is the internetworking protocol. It is the transmission mechanism used by TCP/IP. It is an unreliable connectionless protocol. ARP used to find the physical address if logical address is known. RARP used to find the logical address for the first, if I know the physical address. Now, ICMP is the control messages. If I want to send some query or error messages, then I'll make use of this ICMP. Now, IGMP is group message protocol. If multiple recipients if I want to send, then I will make use of this IGMP. Okay, understood? What are the different types of protocols in network layer of a TCP/IP model? Understood? Yes or no? Yes or no?
Yes, ma'am.
Yes. Okay.
Ma'am. Hello, ma'am.
Hello?
Ma'am, ഒരാൾക്ക് join ചെയ്യാൻ നീരജ് join ചെയ്യാനുണ്ടായിരുന്നു.
You inform the staff advisor because I have not logged in my mail.
Okay.
Okay. Now, coming to the transport layer. Now, the transport layer in TCP/IP, you have got three different types of protocol. One is called the TCP, that is Transmission Control Protocol. The other one is UDP, User Datagram Protocol. And the other one is SCTP, that is Stream Control Transmission Protocol. The major ones are TCP and UDP. Now, this TCP is a connection-oriented protocol, but UDP is a connectionless protocol. Now, this UDP, this TCP, it helps to, the retransmission of packet is possible. Lost data can be retransmitted in this TCP. Okay, but UDP does not matter whether we receive all the data. UDP does not matter whether we receive all the data. Example where the UDP protocols are used is online streaming, what we are doing now, movies, songs, etc. So it does not matter whether it is receiving all type of data. But TCP is not like that. It is used where full data delivery is must. You want to require all the data, and that full data delivery, wherever it is necessary, you will be making use of this TCP protocol. Example, email. Okay, where the data delivery is a must. So you will make use of this protocol, TCP. So main protocols used in the transport layer of TCP/IP is TCP and UDP. Now the third one is SCTP, that is Stream Control Transmission Protocol. Actually, this protocol, it provides support for newer applications. If you have any new applications, example, voice over internet. Now, what is this voice over internet VoIP? Actually, that is a technology that allows you to make calls, voice calls using the broadband services, using the internet services. Other than the regular phone usage or the phone line, you are making use of, you are making a call through the internet. So this protocol supports that, WhatsApp, Skype, etc. So this protocol helps in supporting that application. Okay, so the three main protocols used in the transport layer are TCP, whether it is connection-oriented protocol, where the data delivery is full data delivery is must in this. So wherever is a must, the TCP protocol is made use of. And UDP is connectionless user datagram protocol. It is a connectionless protocol. It does not matter whether we receive all the data. Okay, now SCTP, this type of protocol, it supports newer applications like VoIP, etc. Okay, now the last layer, that is application presentation and the session layer. Now, what it contains? Actually, it consists of some networking application as we have discussed in the OSI model, like SMTP, FTP, HTTP, etc. SMTP, Simple Mail Transfer Protocol for email, FTP, file transfer. For a particular applications, you will be making use of some protocols. So that is the same, similar type in that of the OSI model. Okay, so this is just about the protocols of a TCP IP model. Here you have got 5 layers. One is the physical, data link, network, transport, and the application. So when comparing with the OSI model, presentation session function is also done by the application layer in TCP. Okay, now next is addressing. Actually, this is not there in your syllabus. I'll just give a brief idea about this addressing used in TCP. Already we have covered all these 4 things. And if more idea you will be getting by reading the textbook. So addressing, 4 types of addresses: physical address, logical address, port address, and specific address. cut actually. Hello, you can hear me?
Yes, ma'am.
Okay. How long you were hearing me? Up to where? Which portions? Because I didn't know my network got cut.
Addressing. Addressing.
Did you hear the full thing of addressing? Did you hear the whole thing? Like the physical address, logical address, and port address? No. Okay.
No, only physical address.
I just needed to tell that the to identify a node, okay, as defined by its LAN or WAN. You're not hearing. Yes. Now it is clear. Physical address is mainly used, is the address of a node that is being defined by the LAN or WAN. Can you hear now? Is it clear now? Actually, I have switched to
Yes.
some other using my phone. Okay. Right. Now, the logical address is nothing but it is similar to the, I mean, it is same that IP address. That is, if you want to have, if a computer is having universal, if a computer needs to make a universal communication, then logical address is made use of. Now, port address means if it runs on multiple, if a computer runs on multiple processes, then the port address is must. Now, the specific address is meant for the other type of addressings. Okay. So this is just, I just told about the type of addressing methods used in this TCP IP. Okay. Now, the last topic in the first module is the switching. Switching is, you have mainly got three types of switch networks. One is the message circuit switch network. The other one is the packet switch network, and the other last one is the message switch networks. Now this circuit switch networks, you can just see the diagram. Now what is circuit switching? You have already learned in the subjects like communication and all what is circuit switch networks. Actually, switching is a process that is used to forward the packets coming from one node to another, leading towards the destination. Okay, now circuit switching is nothing but if two nodes communicate with each other over a dedicated communication path. You have a dedicated path. Example is your telephone network. So you have, before establishing the connection, you should have, having the connection, you should establish a circuit for that. You should make use of the resources. Resources, everything should be better planned before making a code. So you have to establish the circuit, you have to transfer the data, and you have to disconnect the circuit. Okay, so that is the function of the circuit switch network. So circuit switching means it is made up of a set of switches. You can just see in the diagram, it is consisting of many switches will be there, and that is connected by some physical links. So resources need to be reserved during the setup phase, then for the transferring of data and the tear down phase. Three phases are there. One is the setup phase, then you have to transfer your data, and finally you have to tear down the data, phase. Tear down phase means you have to end up the circuit, disconnect the circuit. Okay, so this is about circuit switch networks. So example for this is for voice applications. When you are making a telephone call, now what do you have to do? You have to make a virtual path from the user, from the caller to the callee, and once you finish your conversation, you have to disconnect that circuit. Okay. Now the other one is called it as the packet switching. Packet switching means the entire message is broken down into small chunks. You can call it as packets. Okay. Now there is no resource allocation. Similar to that of the circuit switching, you don't have any resource allocation for a packet. It is allocated on demand. It is allocated on demand. Okay. Now you have got two type of packet switch networks. One is the main one is the datagram network. Now, what what happens in a datagram network. Here, each packet, you can see in the diagram, here each packet is treated independently of all others, right? There is no setup or tear down phase in this datagram network. So what it will do is depending, so each of this switch in a datagram network, they make use of a routing table, and that will be a decision taken by the routing table, which route they have to take it and all and everything. The destination address will be inbuilt in that. And finally, through different paths, each of this packet will reaches the destination. Okay, so destination address will remains the same in a datagram packet. Okay, so this is about packet switching. Packet switching means you don't entire data is divided into smaller units called packets, and there is no resource allocation here. On demand, you will be establishing the path. And see, you can see 4, 3, 2, 1 packets, they can have their own way to reach the destination. Okay, so this is about a brief idea about switching, circuit switching and packet switching. Okay, now these were the topics that was there in your module 1. The main thing is the functions of the different layers in the OSI model as well as the TCP/IP model. Started with network fundamentals, then the type of topologies, the type of connections, everything we have learned, then end up with the main models, that is the OSI model and the TCP/IP model. And the first module covers up to this much. Okay, now I'll be just conducting a quiz. Okay, now today only I have got the hour, tomorrow I don't have an hour. So once in your holidays, autumn holidays, I'll be giving you some work for you to do it, and in later time I'll be just informing you what work you have to do it. So now I'm just going to conduct a quiz and link.
മിസ്സേ ക്ലിയർ ആവുന്നില്ല.
ഇത് കേട്ടില്ല.
കേട്ടില്ല മിസ്സേ ഒന്നും പറഞ്ഞേ.
ഇല്ല ഇല്ല മിസ്സേ, ക്ലിയർ ആയില്ല.
ഇല്ല ക്ലിയർ ആയില്ല.
Group, I have shared you now. You take your own, because hours going and be waiting to take the
മനസ്സിലാവില്ല മിസ്സേ പറയാം.
ഒന്നും
മിസ് ഒന്നും ക്ലിയർ ആവുന്നില്ല.
I have sent you a link now. Did you receive? I have sent you a link. Yes, okay. Open that and start attempting by 12:50. If you are able to finish it, good. Otherwise, once you finish your hour at the 1:30, you have to go back again and submit that quiz. Don't do it in the next hour middle. Okay, so try to complete it. You have 10 minutes left now. Can you hear me? Can you hear Afla? Yes. Okay, try to complete it by 12:50. If you are not able to submit it by 12:50, then you can submit it after your 6th hour. No need in a hurry whether you have to submit it or not. So you have the time, because there was some connection mistake. So you can submit it later also. So open that link and try to attempt it now.
Okay.
Okay. Anjali is there or not? Anjali, I'm not finding.
മാം ഇപ്പൊ കട്ടായി പോയതാ.
Ah, okay. Shruti, okay, you are there. So other than Neeraj, all are here, right? Okay, complete that. Read the questions carefully and answer. Don't be in a hurry, like last time few people had just simply submitted that. So take your own time, read the question and then answer it. Vaishnav, Rangit and all, are you attending that? Okay,
I'm
okay.
certain.
Okay. Any doubt, Rangit? Recollect the things that you have learned and then answer.
Network problems on mail service, which was always a
Hello, tell Vaishnav.
അല്ല ആൻസർ ചെയ്ത് കൊടുക്കുമ്പോ ഫുള്ള് പോയി അതുപോലെ
Dhoni?
അത് ആൻസർ ചെയ്ത് കൊടുക്കുമ്പോ കറക്റ്റായിട്ട് അതുപോലെ വന്ന് പിന്നെയും പേരിലടിക്കാൻ വന്നു.
Okay.
Increasing response to standards. In the Osi Model institution.
You have got, I think, 3 more minutes completed because the other staff has joined. So if you are not able to
encryption and
finish it,
discussion, whatever.
Rangit, മനസ്സിൽ വായിക്ക്.
Oh,